The solar magnetic reversal is one of the most intriguing and powerful events in our solar system. Occurring roughly every 11 years, this phenomenon involves the flipping of the sun's magnetic field, where the north and south magnetic poles switch places. Though it may sound alarming, this process is a natural and crucial part of the sun's activity cycle, with significant effects on space weather and potentially on Earth. What is solar magnetic reversal? At the heart of the solar magnetic reversal is the sun's solar cycle. Over approximately 11 years, the sun goes through a period of rising and falling activity. At the beginning of the cycle, the sun's magnetic field is relatively stable. As the cycle progresses, the sun's magnetic field becomes increasingly chaotic due to complex plasma currents within the sun. Eventually, this results in the poles flipping completely, signaling the midpoint of the solar cycle, known as the solar maximum. Why does the sun's magnetic field flip? The sun is a massive ball of hot plasma, and its magnetic field is generated by the movement of this plasma in a process known as the solar dynamo. This movement of electrically charged particles creates magnetic fields that are in constant flux. Over time, the sun's rotation and convection cause these magnetic fields to twist, tangle, and ultimately reverse direction. During this period of magnetic instability, the sun's surface experiences increased solar activity, including more frequent and intense sunspots, solar flares, and coronal mass ejections, CMEs. These eruptions send high-energy particles into space, which can interact with Earth's magnetosphere, sometimes resulting in spectacular auroras, but also potentially disrupting satellites and power grids. The phases of the solar cycle. The solar magnetic reversal occurs during the solar maximum, the peak of solar activity. Leading up to this point, the sun exhibits a growing number of sunspots and other solar phenomena. After the magnetic flip, the sun gradually returns to a quieter phase called the solar minimum when solar activity decreases. Even though this flip happens about every 11 years, the exact timing and intensity can vary. Some cycles have a more dramatic reversal with intense solar storms, while others are more subdued. How does solar magnetic reversal affect Earth? The solar magnetic reversal has a profound effect on the entire solar system, but especially on space weather, which can influence Earth in several ways. Increased solar flares and CMEs. During the solar maximum, the sun releases powerful flares and bursts of plasma, which can interfere with satellites, GPS signals, and even power grids on Earth. This is why space agencies and technology companies closely monitor the sun during these periods. Radiation hazards. For astronauts and spacecraft outside Earth's protective atmosphere, increased solar activity poses a greater radiation risk. As a result, missions to space are often carefully planned to avoid the solar maximum. Beautiful auroras. On the upside, the increase in charged particles interacting with Earth's atmosphere can produce stunning displays of the northern and southern lights, auroras. Impact on Earth's climate. While still a topic of ongoing research, some studies suggest that changes in solar activity during the magnetic reversal could influence Earth's climate, although this is debated and likely has a minor effect compared to other climate drivers. Preparing for the solar magnetic reversal. While the solar magnetic reversal doesn't pose a direct danger to life on Earth, its potential impact on technology means it's important for certain industries to be prepared. Power companies, satellite operators, and airlines are particularly vulnerable to the disturbances caused by solar flares and CMEs. What's next for the sun? As the sun progresses through its current cycle, researchers are closely watching for signs of the next solar maximum and the magnetic reversal. Instruments like NASA's Solar Dynamics Observatory, SDO, and the Parker Solar Probe are providing valuable data, helping scientists understand the inner workings of the sun and better predict the effects of these solar phenomena. The solar magnetic reversal is not just a reminder of the dynamic and ever-changing nature of our star, but also a critical component of space weather that affects life on Earth in surprising ways. In short, the sun's magnetic field flip is a fascinating and regular event that underscores the powerful forces at play in our solar system. As we learn more about it, we gain better tools to predict and protect ourselves from its more disruptive effects, while continuing to marvel at the mysteries of the universe.